All right, let's take a look at a few more examples. So number one here, this one's not factored, right? So the first thing we want to do is set one side equal to 0. So that's already done. So then we want to try to factor the other side, right? So here we have a simple quadratic, right? We have an invisible 1 there in front of x squared. So we can just set it up like this. Put the 0 there. We can put an x here and an x here. And we don't have to worry about multiplying a times c. We can just find numbers we can multiply to get 6 that we can subtract to get 1, right? So numbers we can multiply to get 6 that we can subtract to get 1. So those are 3 and 2, right? Or 2 and 3, doesn't matter what order. So then remember, this tells you your sign are the bigger number. Okay. And then this tells you if the signs are the same or different. Okay, negative means different. And so that means this is going to be negative. All right, and now you can just set these equal to 0, right? In order for this to be true, either that has to be 0 or that has to be 0, right? So either x plus 3 must be 0 or x minus 2 must be 0. So then you just here subtract 3 from both sides. So you get x equals negative 3. Or here you can add 2 to both sides and you get x equals positive 2. So those are your two answers, okay? All right, number 2. Now, here we finally have something where we have one side that's not 0, right? So I want to get one side to be 0. Now, you could do it either way. There's two ways you can do it. You can get this to be 0 by adding 3x to both sides, right? Using our addition property of equality. Or you could get the other side to be 0 by subtracting 3x squared to both sides. Okay. Now, here's what I would recommend is try to get your a to be positive when you're factoring out quadratics, right? We want our leading coefficient to be positive. So wherever the x squared is going to be positive, that's where you want to bring your x's in all your terms, okay? So since 3x squared is positive already on the left side, I'm going to bring everything else over to that side. Okay, so I want to keep 3x squared positive. So that brings the other 3x over and get equals 0. So now I got one side to be 0. The second step is I want to factor completely, right? So this is a quadratic, right? Because we have x squared, but it's not a trinomial. So we're not going to get something well, actually, let's go back for a second. If it's a difference of squares, that could work, right? That gets us something like this. If it's not a difference of squares, then it's probably not going to give us something like this, okay? So binomials can sometimes give you a product of two binomials when it's a difference of squares, but usually they're not, or it's not generally going to happen. So, but here I have a common factor of 3, so I'm going to bring a 3 out. Then I also have a common factor of x. And I'm going to take the one with the smallest exponent, right? So that's x to the first. Okay, then I'm going to put my leftovers back inside. So if I do 3x squared divided by 3x, I get x. And if I do 3x to the first divided by 3x, I'm going to get 1, right? So notice they do cancel out here, but they cancel to 1, right? So sometimes people just leave that blank and put 0 or put 0. But remember that when you're factoring, you're dividing. And so you're always going to have at least, you're going to have a number in both those positions. And if something cancels out, you'll have at least 1. All right. And so now I have that equal to 0. So now I have two things that I'm multiplying together that could equal 0. This time it's not a binomial, but it still could equal 0, right? 3x could equal 0, or x plus 1 could equal 0. And so what we'll do is divide both sides by 3 here, and we'll get x equals 0. 0 divided by 3 is 0. Or here we're going to subtract 1 from both sides, and we get x equals negative 1. All right. Okay, take a look at number 3. Number 3 is, it's already factored for us, right? But we have one side that equals 14. So what do we have to do with that? We actually have to FOIL in this case, because we can't use the zero product property here, right? Because there's a lot of ways you can get 14, right? 14 times 1, 7 times 2, and even beyond that, you can get into fractions and decimals, and there's just a lot of ways you can get 14. There's an infinite amount of ways. And so what we need to do is we actually need to FOIL this out and then move the 14 over, and then we can get one side to be 0 and go from there, okay? So I'm going to multiply 2x times x, which is 2x squared. 2x times negative 1 is negative 2x. 1 times x is 1x. And 1 times negative 1 is negative 1, okay? So I'm going to combine like terms here. I'm also going to subtract 14 from both sides. So I'm going to kind of do two steps at once here. Okay, so I get 2x squared. Then I'm going to combine these like terms. Negative 2x plus x is negative x. And I'm going to combine these. Negative 1 minus 14 is negative 15. All right. So now we have one side equal to 0. And so now we can try to factor, right? So since there are no common factors here, and a is bigger than 1, this is going to be a complex quadratic, right? Or complex trinomial. So we're going to do 2 times 15 gets us 30. So then we can just start with 2 and 15. And you might already know it right off the top of your head. That's great if you do. But we're trying to find numbers we can multiply to get 30 that we can subtract to get 1, okay? Numbers we can multiply to get 30 that we can subtract to get 1. Now 15 minus 2, that's not going to work, right? That's 13. So then we check, we want to get these numbers closer together to get a difference of 1. So then we want to get this number bigger with the smaller number here. So 30 divided by 3 is 10. 10 minus 3 is 7, so we're getting closer, but we're not there yet. So we check 4. 4 doesn't go in. 5 goes in 6 times. And ding, 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 there's our winner, right? So we can set it up. We can put an X here, leave a little space in front, put an X here, leave a little space in front. Now we're going to put these values here, 5 and 6. Okay, remember this is the sign of the bigger number, so 6 will be negative. And this tells us the signs are different, right? If this sign's negative, the signs are different. So that means this will be positive. Okay, so now we're going to set it up again as equations. 0 factor property, right? If those are multiplied together to get 0, one of them has to be 0. All right, so then x equals negative 5. And for this one, I'm adding 6 to both sides. So I'm going to get x equals 6. All right, let's take a look at number 4 now. So number 4, it's already set to 0, so we don't have to worry about that. Got a lot going on here, so let me kind of clean this up here. Okay, so I already have one side equal to 0, and this looks like a complex quadratic, right? 5 is out front there, it's bigger than 1. However, we do have a GCF, right? So we always want to check for the GCF first. And here 5 goes into all those numbers, right? So I can divide everything by 5, and I'll get x squared minus 6x plus 9. Okay. All right, so now it's a simple quadratic, but it's actually also a perfect square trinomial, right? We have a perfect square there, perfect square there. If we take the square root of both, we get x and 3. If we multiply those together, we get 3x, and if we double it, we get 6x. And so that's a perfect square trinomial where we're going to get something like this, x and 3. Okay, so we put those square roots in there. This sign is the one that comes down here, so it's going to be x minus 3, and then it's going to be squared equals 0. Okay. Now remember, another way you can write that is x minus 3 times x minus 3. Right? That's the same thing as saying x minus 3 squared. But when you set these up for an equation, either way you're going to get the same equation, right? So either way you'll get the same answer. So x minus 3 equals 0. That's easy to solve. I don't even have to worry about the other one. So I can just add 3 to both sides. And so I get x equals 3. All right.